Hi, I'm Fatma Abdelkafi, a principal data scientist in Infor and a multidisciplinary engineer. So I have experience with retail demand forecasting and machine learning forecasting.
Hello, my name is Ahmed Rudi. I'm an associate scientist at Infor Decision Science and Analytics team. I have experience implementing and tuning ML models, mainly for forecasting problems.
Today, we will work on Hello World of Machine Learning using Coleman AI. Before we get into it, don't forget to like this video and subscribe to our YouTube channel. Okay, so today, Ahmed, I have iris flower dataset, and I want to build a machine learning model using Coleman AI. So the data set consists of 50 samples from each of 3 species of iris: Iris setosa, Iris virginica, and Iris versicolor. 4 features were measured from each sample: the length and the width of the sepals and petals in centimeters. So my goal here is to design a model that makes useful classifications for new flowers using these 4 features.
Okay, so we need a model to distinguish the species from each other based on the combination of these 4 features. So this seems to be a classification project since the variable that we want to predict is categorical.
Okay, I will show you how to build this model in Coleman AI, and you can show me how we can work on this problem using custom algorithm feature in Coleman AI.
Sounds good.
Perfect. So to build the model in Coleman AI, we have to import the data, build the training quest, and then the production quest. After that, we need to deploy an endpoint. Once we have the endpoint ready, we can query it either directly or from an API.
To import the dataset, we should go to the Datasets tab here, and there we can see all the datasets that are available in this environment. Also, we can add new ones. So to add a new one, we should click on Add, and we can either add the data from Infor Data Lake or from a file. In our case, we're gonna use a file, and we should choose the file from our local machine, and then we can change the delimiter. By default, it's comma. The name of the data, I'm going to choose iris, and when hitting preview, we are going to see the 100 rows, the 100 first rows from the data. And as you see here, the first column is class, and it's gonna be 0, 1, or 2 for iris setosa, versicolor, or virginica, and that's gonna be our target. And the 4 other columns are the variables, and these are going to be used as input. So I need to hit save so we can have the data loaded. Once the data is loaded, I can see here the data is loaded. I can see the statistics, and here in the info I have 150 rows, no missing values, and 5 columns. Here I can see the histogram for these 5 columns, and specifically for the class, we can see here that we have 50 from each one of the classes. That's it for importing the data. My next step is to create the training quests. So to do that, I should go to the Quests tab. The Quests tab here, you can see all the available quests in the environment. And there, to add a new one, we should hit Add. I'm gonna call my quest Iris Classification. And so here the quest is a sequence of activities from importing the data to evaluate the model. So I'm going to import my data. That's my first activity, and I should specify here iris, which is the dataset that I have loaded earlier. Next, I'm going to identify my label, and that's part of preparing my data. There, my label is class, and the categorical value is categorical. Machine learning type should be label. The next activity is identifying the features, and I'm going to select the rest of the columns and say that these are features. I have my data ready. Now I want to split the data into a training set and test set. So 70% is going to be training set and 30% as test set. So now I'm going to train my model. The first input to my model is the dataset, and the second input is the algorithm. My algorithm that I'm going to use today is XGBoost, and that's my second input. So here for XGBoost, I can change the parameters, and as Ahmed said, this is a multi-class classification, so I'm going to use the softmax multi-class classification, and I'm going to keep the rest of the parameters the same. I'm just going to make sure that I'm using 3 classes, and that's the case. For trained model activity, the label column is class as specified in identify label activity. Later, I'm going to evaluate, select score model from evaluate model activities. And the first input to that activity is the test set, so which is the 30%, and the second is the output of the trained model. Okay, and finally we are going to generate the error matrix in evaluate model. So we have our training quest ready. We just need to save it and then run it. Like as you see here, the quest is saved as a draft, and then I need to run the quest, and then the training quest status change it to running. Now these circles here, this means that the activities are queued. When you see that it is similar to a clock, when it's turning, it means that it is running, and when it's green, it means that the activity has run and it was run successfully. So the quest will take from 5 to 6 minutes to finish. So the training quest has finished successfully, as you see here in the status, and we see that for each one of the activities there is a green circle, means that all the activities run successfully. We can see the output of each one of the activities. Here this is importing the data. As you see from class, here the class, I can see the statistics that I have shown you in the when importing data, and the ML type is feature, and here the output of the second activity shows that my ML type is label for the class. Okay, so here I can see the model, the output of scoring the model. So I can see my predictions, and here I see the predicted class, and I can see the output of the error matrix, and I got 91% accuracy, and this is the confusion matrix. Now I should create my production quest, and to do so I'm going to select the activities for my production quest. So it's gonna be importing the data, identifying the features and the labels, and here training the model. And I'm gonna hit save, and by clicking on this production quest, it's gonna the production quest will be generated. Hit the yes. So here is the production quest, where it is a sequence of activities that should be run when we want to generate our prediction. So from ingesting the data to doing to preparing the data, and then the predictor is using the output of the training model. So now I should run, so it's saved in a draft mode, and I should run the quest to get the final quest finished. Now the production quest has finished running, and the status has changed to finished, and for each activity we see that there is a green circle. What happens here is we ingest or we use a sample from the dataset that we have input, and we apply these modifications, and then we use the trained model and get some predictions here. As you see, here is the predicted class for the sample dataset. Okay, so once we have our production quest ready, we need to create our endpoint. So the endpoint is something easy to deploy once we have the production dataset by clicking deploy endpoint. So we are going to create the endpoint iris classification, and we just need to create. So you see here that my training quest has finished, my production quest has finished, and my endpoint is creating. The same here in the quest property, I will see that my endpoint is creating. The endpoint is ready, and as you see here, it is active, and here it shows as active, and we can access the endpoint either from this link or this link. So clicking on this link, and you see here the endpoint, and it is active, and I can query it either from a file or a JSON message. Also, there is another way to access the endpoints, is to go to the endpoints tab. There you will see all the endpoints that are available in the environment, and by clicking on this iris classification, I'm gonna get to my endpoint. And for today, I'm going to just query using the JSON message. So I'm gonna pick here 1.1, 1, and 3. And by clicking predict, I'm gonna get the predicted class. Here the predicted class is 2. Okay, another way to query an endpoint is using the API. So what we should do is to go to Infor API icon here, and there in the available APIs, we should go to the Infor Coleman AI platform API and click on documentation. Here we can see we should try it out, and our endpoint name is iris classification, and what we should enter here is the data in the following format. So each one of these is an instance or an observation that we want to predict the class for. So here I have 3 observations, and I'm gonna execute. All right. So the response to this query is the following, and you see here the endpoint has returned the classes or the predicted classes for the three observations that I have put in the input, and it's 2 for the first one, 2 for the second one, and class 0 for the third one.
Thank you, Fatma. Now let me show you how we can use the custom algorithms feature in Coleman AI to solve this problem. So my algorithm will be a neural network classifier written in TensorFlow, and since I want to use it instead of the predefined ones, I need to use this feature. So first thing you need to do is go to the Custom Algorithms tab in the Coleman AI platform and click on the Add button. This is where you upload your algorithm, but before we get there, we need some guidance on how to implement it. Luckily, if you go to the Instructions tab, you'll find a lot of information that helps you with that. And you'll be able to download a template for your algorithm. Let's go ahead and do that. So we're going to use this template that we just downloaded to write our code and test it locally on Docker before we upload it back to Coleman. And after extracting this template, we'll be presenting with a directory containing this Docker file and following scripts. However, we're only interested in modifying train, predictor.py, and unicorn. We also, here I already added the required Python packages to run my train script. So if we take a look here, these are the packages for my specific algorithm. So let's start with our train script. So the coolest part about this is you can write virtually any algorithm you want as long as you install the needed dependencies and save a model in the end. So which is what I did here. So this part of the code, I'm installing the needed dependencies, and in the end here, I'm saving my model. Basically, these are the steps that you generally would repeat from for whatever algorithm that you want to implement. So here the template will look the same in these first, the directories, the paths, and so on. This function will always be here, reading the hyperparameters file and the training data. And the rest here is up to you what you want to do. So in this case, I'm just writing a simple classifier using TensorFlow, and that's it. I'm training it. So since we're done with our train script, we want to make sure that it works as expected, and to do that, we need to use Docker. So I'll go to directory containing my Docker file and open a terminal here. Okay. So first in Docker, you need to build an image. So we do that using the build command, docker build, and this T flag allows me to specify a name for it. I'm just going to call it TF classifier. And then we tell it where the Docker file is. It's in our current directory. That's it. Now we want to run our train script in our container. And to do that, we need to use this Docker command. Here, I'm using an old command and modifying some stuff. So the paths needed and the name of the image. So I'll explain a bit what this command does. So here we're specifying the path on our local machine and what it should correspond to on Docker. And here the ports, actually this is not necessary for this command. Just we don't need this. And that's it. And then the name of the image and the script that we want to run. So let's go ahead, do that. So as you can see here, it's installing our dependencies. It will take a moment. That's it. Training is successful. So now that we made sure that our training script works as expected, let's, since all is good. So now, before we move on to the script that generates the predictions, we need to install the dependencies needed to run it. We do that here in unicornconf.py. This is not the same as in what we did in the train. In the train, we installed the dependencies in using the same script, but here there is a requirement that we do that for the prediction in this unicornconf file. So that's it. I'm doing that here. Now for the prediction, we need to load the model that we saved earlier, if you remember, at the end of the train script, and write the code needed to generate the predictions. And our output should be a list of comma-separated string values. So here, basically, we don't need to make a lot of modification. This get model, I'm loading the model in this line of, using this line of code. And then there is this predict function. I'm using like my model to generate predictions and making sure that my output or my predictions are a list of comma-separated string values. So that's it. Let's test it as well. In order to do that, we use the same previous command. Instead of train, we want to run serve. This is a script provided in the template that we downloaded. And we also need to add up this specify port for this command to run. This starts a server for us to query and get our predictions back. Okay. So here it's also installing the dependencies, as you can see, for the prediction or for the predictor script. It will take a few minutes. So wait for it. That's it. It's now waiting for us to query it. So how do we do that? Well, we go to the file that we want to use. Like we want to get predictions for. In this case, I prepared this CSV file. It's iristest.csv, and it looks like this. It doesn't contain a header. These are my features. Okay, so let's open a terminal here. You need to run a curl command. So as you can see, I'm specifying the data that I want to use for this prediction, and basically this is a typical curl command. This here is implemented in our predictor invocations. It will call a function in our predictor. So that's it. As you can see here, we have our predictions ready and it looks good. So now that we made sure that our code works in our in Coleman in Docker, excuse me, we just want to zip it and upload it back in Coleman. I already prepared that here. So if we look inside the zip file, we'll have our dependencies, unicornconf, predictor.py, and train. And these are the needed scripts. Actually, we don't need to include those, but it doesn't hurt also. So this I kept them to show you that you can add your own scripts if you want to write a separate modules and use them in your other scripts. So once this is done, we go back to the platform, and this is how we do it. So we go here, we select our algorithm, the file, and if we have a hyperparameters file, we do it here. In most cases we do, and here I decided to make some hyperparameters like configurable. Obviously, you'll have a lot more in a real use case. Once this is done, we just give it a name and we click the save button. Here I'm not going to do that because it will take a while to upload, but once that is done, we click on the deploy button and the result will look like this. So we will have this status ready and our classifier and the hyperparameters file. So that's it. Now that we made that our custom algorithm is ready, we want to use it in a quest. So our quest will look like the previous quest that you showed. There are the same steps here, but the difference comes in these three activities: custom algorithm, train model with custom algorithm, and core custom algorithm model. So these three activities are new, and I'll explain them one by one. So this one here, basically we just specify what algorithm we want to use. The hyperparameters, we can configure them here, and that's it. This next activity, called train model with custom algorithm, takes as input the custom algorithm and the train data here. The only thing that you maybe want to change, depending on your case, is this, whether your input data has a header or not, but this is pretty straightforward. Next box, activity. Yeah, I'm calling it. So next activity takes as input the output from the train model with custom algorithm and the test data. And when you run the whole quest, you'll get the predictions here. So I clicked on the, for people who missed it, so on this small circle. Basically, this is the output of this core custom algorithm model. This column here contains our predictions. So it looks like it's performing pretty well compared to the expected target. And that's it. The rest of like the production quest and the endpoints is exactly the same as shown earlier in the video, and that's it. Thank you.
We hope you have a good overview on how to build machine learning models in Infor Coleman AI using native algorithms and custom algorithms. All this is done with the basic example of iris classification.